Good afternoon, 6th grade. It is Tuesday, April 28th, and today we're going to be learning about time around the Earth. This is going to be our theme for this week, latitude and longitude and time. And you guys, at first going into this, when you look at this giant fact page on this one, you're going to probably freak out and be like, I can't do this, this is too much. Once we read through it all and I explain to you how each part is used, it's very straightforward. And I hope everybody did well on the test yesterday. You're not disappointed in yourselves because you guys are really smart. I know you can do it. So let's read about this fact sheet. The Earth takes 24 hours to complete a full revolution of 360 degrees. In 1 hour, it rotates 1/24th of a spin, or 15 degrees. In 4 minutes, it rotates 1 degree. Make sure you remember that part. Every 4 minutes, 4 minutes equals 1 degree. That's going to come in handy later. Alright, so imaginary lines that run from the north to the south poles are called meridians of longitude. 0 degrees longitude passes through Greenwich, England, and is called the prime meridian. When Greenwich is exactly in line with the sun's rays, the time there is noon. Traditionally, noon is written as 12 o'clock m, however it is commonly written as 12 o'clock p.m. This time is Greenwich Mean Time, and was the basis for time around the world before 1970. GMT is based on the rotation of the Earth, which can vary slightly due to the Earth's wobble. Therefore, Coordinated Universal Time, which is based upon the atomic clock, is now our standard. And it loses no more than 0.000001 second in 1 year, so it's very reliable. Until the age of modern travel, communities used to regulate their own time, but in 1884, an international conference established 24 time zones. 12 are east of the prime meridian, and 12 are west of it. The 12 zones east and west are half zones and are separated by an imaginary line called the International Date Line. The IDL is opposite the prime meridian. So prime meridian goes this way, the other zones go this way. Time zones, including the prime meridian and the IDL, differ from meridians of longitude in that they are not straight lines. Time zones are made to work with boundaries of states and countries as much as is reasonable. The time zones for the United States are Eastern, Central, Mountain, Pacific, Alaska, and Hawaii Aleutian. In each time zone, the clocks are 1 hour earlier than the clocks immediately to the east. So for instance, we are in Central Time. It is 5 o'clock here. But in Tallahassee, which is an Eastern zone, it is 6 o'clock. But if we go to the Mountain Zone, which is the west of us, it would be then 4 o'clock. But then if you went to the Pacific Time, it would only be 3 o'clock. So each time zone you move to the east, you go up an hour. Each time zone you move to the west, you go back an hour. So a traveler going east-west across the date line, though, must set his calendar back 1 day. So if I'm going east this way, I have to actually move my calendar backward. But if I'm moving west, I have to move it up 1 day forward. From the second Sunday in March to the first Sunday in November, many regions use daylight savings time. This means the clocks are set 1 hour ahead of the standard time for that zone. Spring ahead in the spring and fall back in the fall. Many countries don't do it anymore. The United States still does. So let's look at this class practice using our formula here. Every 4 minutes equals 1 degree. So if the Earth moved 2 degrees, how long did it take it? Well, if 1 degree is 4 minutes, 2 degrees is 8 minutes. That's right. Another way you can calculate it is go 4 times 2 equals 8 minutes. All right. How about 24 degrees? Once again, our formula. For each degree, it's 4 minutes. So 24 times 4. 4 times 4 is 16. Carry a 1. 4 times 2 is 8. 96 minutes. But we want to convert this to proper. So I wouldn't say 96 minutes. I would say subtract 60 for an hour and 36 minutes. Because remember, how many minutes are in an hour? 60. That's right. All right, so that's how you do those. Let's work another one. How about 100 degrees? How many minutes would 100 degrees take? Well, we use our formula. 4 minutes per degree, so 400 minutes, but we got to reduce that. So we know it's 60 minutes per hour. How many times can 60 go into 40? Well, 6 times 5 is 30, so 60 times 5 is 300. Let's try 6. So 6 times 60 is 360. Yeah, so we're left with 40 minutes. So we got 40 minutes and 6 hours. There we go. 6 hours and 40 minutes. Because remember, each 60 minutes is an hour. You can get 6 hours out of that because there's 360 minutes plus an extra 40 minutes. Almost 7 hours. It takes almost 7 hours for the Earth to rotate 100 degrees. Understand how I did those? Pretty straightforward. You just take your degrees, multiply them by 4, and if you can convert it to hours, do so. And if you leave it as minutes, you can. I just prefer it to look nicer. Alright, let's see here. Complete this chart of the United States zones. Okay, so remember, look at the top one. If it's 3 a.m. in Hawaii, Aleutian, it's 4 a.m. in Alaska, 5 a.m. in Pacific, 6 a.m. in Mountain, 7 a.m. in Central, 8 a.m. in Eastern. Remember, you go forward when you move to the right. You go backwards one when you move to the left. So let's look at chart B. So it's 4:30 a.m. in the Pacific time, which means it is that's right, Lucy. It's 3:30 a.m. in Alaskan time, 2:30 a.m. in Hawaii and Aleutian. But if I'm moving to the right, if it's 4:30 Pacific, it is 5:30 Mountain, 6:30 Central, 7:30 Eastern. You move an hour to the right each time zone, an hour to the left each time zone. Alright, let's see here. Solve these story problems. Jeff left the city located in Mountain Time at 3 p.m. and traveled for 5 hours to a city located in Pacific Time. Okay, so let's see here. He's in Mountain Time, and he traveled 8 hours. But how many hours difference is there between the Mountain and Pacific Zone? 1 hour. So even though he traveled 8 hours, it's only 7 o'clock in the Pacific Time because he lost that hour traveling backwards. Because really, when he left his house at 3 p.m., in Mountain Time, what time was it really in Pacific Time? It was 2 p.m. So he didn't really lose the hour, he was just going back a time zone. It would still be 8 o'clock in Mountain Time, but remember, it's always an hour back per time zone. Alright, and then change from standard time to daylight savings time. Remember, you bump it an hour forward. So 5 p.m. becomes 6 p.m., noon becomes 1 p.m., and 3 a.m. becomes, bump it up an hour. You got it. Alright, now let's look at 5. Convert to the nearest whole degree. Remember, you round it up if you have to. The only one you should have to do that on is B and C for these, but you got it. You got these. Let's see, 6A, B, those are just solving for X. You know how to do those. And then on 7, just do A, B, and E. Pretty straightforward stuff. You know how to do those 3, A, B, and E on 7. That's all you got to do for 7. I'll see you guys again tomorrow.